For 1.6 part A, we're going to mainly be focusing on rational equations. Remember that a rational function or a rational term is basically a fraction, ratio fraction. The first thing that we'll have to be worried about is the domain. Remember that we cannot have division by 0. So for number 1, we're trying to figure out when is this expression undefined, meaning when do we have division by 0? Number 1 commandment of math. So the denominator is all we're really concerned about here. We do not want the denominator to be 0. Well, if I factor it, if you factor it, it'll be x minus 5, x plus 2. The numbers that would make it 0 would be 5 and negative 2. So those are the values that make it undefined. Remember, these are not solutions. This is not an equation. This first problem has no equal sign. I'm not solving anything. I am simply saying these are the numbers that are not allowed to go into that function. That'll have to be a theme as we're doing the problems here. We've got to check, is something going to make it undefined? Does it cause division by 0? So here's how we're going to solve rational equations. It's going to be very similar to what we did with combining them, where we need to get the LCD. So for 2a, my least common denominator, well, I've got a 3 and an x minus 1. They have no common factors, so I need them both. Now, a little bit different than what I did when I was just combining, trying to add or subtract fractions. I'm going to multiply everything by the LCD. The idea here is fractions are scary. If I multiply everybody by the least common denominator, all the fractions will reduce out. So for the first one, so I'm looking at this part right here. The 3's would cancel, and I'd be left with x minus 1 times 3x minus 1. You'd have to FOIL that out, and you'll get 3x squared minus 4x plus 1. For my second part, so now I'm looking at, let me change the color here. So now I'm looking at this part. The x minus 1's will cancel. And so I'm just left with 3 times 2x, but careful, it's actually a negative 2x. That's going to be minus 6x. On the other side of the equation, this is x times 3 times the x minus 1. So what I can think of this as is just 3x times x minus 1. I'm going to distribute. So on the other side of the equation, I'm going to get 3x squared minus 3x. So I went from an equation that had fractions, which made it seem very terrifying, to an equation that doesn't have fractions. Well, if I look at my equation now, I've got a 3x squared on both sides. So if I subtract that off, it's gone. Let's combine some like terms here. So I have negative 10x on the left plus 1 equals negative 3x. I'll group together my x's. So now I have 1 equals 7x. And if I divide by 7, I get x is 1/7. Now, remember what I mentioned at the top. I do have to be aware that I could have division by 0. But looking at my original, 1/7, if I plug that in any denominator, which really would be there, that does not cause division by 0, so 1/7 is good. We'll see some examples where answers have to get tossed because they cause division by 0. For letter B, again, I need to figure out my least common denominator, which in this one is actually easy. The least common denominator is simply x minus 2. That's the only factor I have in the denominator. So I'm going to multiply every term by x minus 2. And again, the logic behind this is that it will clear out fractions. So on the left side of the equal sign, x minus 2's cancel. I'm just left with x. For the next term, x minus 2's cancel. I'm just left with 2. For the last one, I have to multiply 2 by x minus 2. So that's going to give me 2x minus 4. And I'm ready to solve this. So I'd have 2x minus 2 when I combine those terms. If I subtract over 2x, I've got negative x equals negative 2, which means x equals 2. But remember, rational functions, we can't have division by 0. So looking back at my original, oh crap, 2 would cause division by 0. So basically I'm saying I can't take the number 2 and plug it back in because it would cause division by 0. So the answer I got doesn't work. This is an empty set problem. There is no solution to that equation. For letter C, okay, I've got to figure out the least common denominator. Obviously, there's a lot more going on here. It's always a good practice, if you see something that can factor, factor it. X squared minus 9 factors into, conveniently, x minus 3, x plus 3. So looking at my denominators, it's my least common denominator is going to be x minus 3, x plus 3. That covers all the denominators. So each term, and this is going to start to seem a little cumbersome to write all this, but I want you to get into the practice of it so we see what we're doing. Each term is going to get multiplied by x minus 3, x plus 3. I'm going to change colors so we can differentiate these. X minus 3, x plus 3. And even on the right side, x minus 3, x plus 3. Okay, so for the blue part, the x minus 3's would cancel. And I'd be left with 1 times x plus 3. So that's just going to be x plus 3. For the red stuff, x plus 3 cancels. So I'm left with 1 times x minus 3. That's just going to be plus x minus 3. And on the right side, both of them cancel. So I'm just left with 10. So a much simpler looking equation than what I started with. So that's going to give me 2x equals 10, x equals 5. Remember, I need to check, would that cause division by 0 in any of my denominators if I plugged in 5? 5 would not cause division by 0, so we're good. 5 is an answer. For letter D, again, if something looks like it can factor, we probably should factor it. In this case, the x squared minus 3x, I can bring out a GCF of x. And so I change that denominator. And conveniently, I can see that those are the other factors in the other denominators. So that means my LCD is x minus 3. So just like the last one and all the other ones, I'm going to multiply both sides by the LCD. I'm sorry, every term, excuse me, by the LCD. And just so you know, this is legal math move because I am multiplying both sides of an equation by the same thing. So it does preserve the equation. So with the red stuff, X's cancel, X minus 3's cancel. I'm just left with the number 3. For the blue stuff, X's cancel. I'm left with 4 times X minus 3. So that's going to be 4X minus 12. And for the green stuff, X minus 3's cancel. I'm left with 1 times X, X. All right, solve through. I've got 4X minus 9 equals X. Let's say I subtract over the 4X. That would leave me with, I'm going to write it over to the side here, negative 9 equals negative 3X. Divide by negative 3, X is 3. But again, I have to check, does that cause any division by zeros? Yes, it would. As long as it does it one place, we got to toss it. Right there it would, and technically, actually, it also works there. So it causes a division by 0. It's tossed. This is another no solution problem. For letter E, my LCD on this one actually is a little simpler. It's just x squared. Because x squared is just x times x, and the other factor is just an x. That factor of x is within the x squared. So I'm just going to multiply everybody by an x squared. So x squareds cancel in the first one. I'm just left with a 2. On the second one, careful, x in the denominator will cancel with one of the x's in the x squared. That'll leave me with minus 31x. Nothing cancels on the right side, so I'm just left with 16x squared. All right, this is shaping up to be a quadratic. I'm going to move everything over. I'm going to move it over to the right side, simply because I like my squared term to be positive. So my quadratic is going to be 16x squared plus 31x minus 2 is 0. This, it turns out, is factorable. We haven't done an x box in a little bit, so let's do one. So a times c goes up top. That's going to be 16 times negative 2, so negative 32. B goes on the bottom, which is positive 31. The numbers that multiply to negative 32 and add to 31, hopefully that should be fairly simple. That's going to be 32 and negative 1. Now I go from x to box. First term, first box. Last term, last box. The 32 and the negative 1, oops, 32 and the negative 1 go in with the variable attached. And remember, I'm bringing out the GCF of each row and column. I'll make myself a little room here. So top row, they have an x in common. Bottom row, they have a 2 in common. First column, they have a 16x in common. Since I have a negative on the 1x, I got to bring a negative out. All they have in common is a 1. You've always got to bring something out. Even if they don't have anything in common, there's always a 1. So my factors are 16x minus 1, x plus 2. Remember, this equals 0. So the solutions would be, for the first one, 1/16 makes that 0. The second one, negative 2. If you check, neither of those answers makes a denominator 0, so we're good. Number 3 is a different type of problem. It is a quadratic-like equation. It's not a quadratic because quadratics only have x squared for their highest power. This has an x to the fourth. But the pattern of this problem is very similar to a quadratic. So here's what I mean. This is still going to be factorable. It's just going to look a little different. Usually we put an x at the beginning of each one of these because we know it has to multiply to x squared. But this one has to multiply to x to the fourth. Well, that means each one of these is going to actually just be an x squared. I still run this like a normal x method problem. It'd be the numbers that multiply to -10 and add to -3, which we did actually at the beginning of this lesson. This would be a +5, oh no, excuse me, a -5, -5, and a +2. Oops, wow, I'm all over the place. But I can't just say, oh, my answer is 5, my answer is -2. And the reason I can't is because it's x squared. So I've got to think zero factor property. I want this factor to be 0. So that means x squared minus 5 has to equal 0. If I solve through, that means x squared equals 5. And then I have to take the square root of both sides, which is going to give me plus or minus √5. For the second factor, x squared plus 2, again, I want that to be 0. If I subtract over 2, I take the square root. Again, I'm going to get a plus or minus. Now remember, this is the square of a negative, so I can remedy that by just saying I √2. I also want you to notice that I really got 4 answers. I got positive √5, negative √5, positive I √2, negative I √2. That's 4 answers, and notice that the problem was an x to the fourth. That's not a coincidence. We'll actually learn later on that whatever our power is, our highest degree, we will get that many answers.